So the algebra review that you see here, it will not be anything new. We're going to break it down into 4 pieces. For Monday, we're going to do problems 1 through 8. So if you want to highlight problems 1 through 8 for yourself, I kind of highlight in different colors so that I can keep track as we go through this. So 1 through 8 is due, hopefully by the end of class, you'll get it done. What my goal is, I'm going to do like half of the problems with you, and then you'll do the other half on your own. So let's go ahead and start with problem number 1. Now, problem number 1 is just a substitution. We're going to evaluate the expression 4x minus 5 for each value of x. So I'm going to do A, then you do B. Okay, so if x is equal to 1, remember, when doing substitution, here's my trick, the way that I always do it. Where the x is sitting, put a little parenthesis, and that's where you want to substitute in your value. And then you just got to follow your order of operations. So this should have been a very quick, easy problem for you. So we would get negative 4 minus 5, which is equal to negative 9. So that's A, and then please do B on your own. Okay. Now 2 is the same thing, except we have a little bit more pieces and parts, a little bit more order of operations that we would be doing for number 2. So let's do A. Again, where the x is sitting, put yourself a little parenthesis there so that you can just plop in the information. So for A, we're again plopping in negative 1. Now here's where people make mistakes. So let me remind you of some stuff. You're going to square the negative 1 first. Negative 1 squared is positive 1, but there's an opposite there. That negative on the outside makes it negative 1. So we're going to actually end up with negative 1 minus 9 minus 8, which is negative 18. So then you go ahead and try it for B. Okay. So 1 and 2, easy substitution. Don't forget your order of operations. Now, let's talk about problems involving number 3. Now, we might do actually more than half of them, but I just want to remind you of some things. Okay. So let's first start with A. So A and B, you might notice, or I'm sorry, A and C, you might notice are the addition or subtraction of fractions. What do we have to have in order to add or subtract fractions? What do we got to have? Got to get that common denominator, right? So in the top here, all of those values, the least common multiple of 8, 12, and 3 is 24. So you just got to think yourself, what could I multiply those denominators by to get 24? Well, our first one here, we would multiply our first fraction by 3 on top and bottom. So that's why we'd get a 9. Our second fraction, we would multiply by 2 on top and bottom. That's why we get a 6. And our last one, we would multiply by 8 on top and bottom. And that's why we would get an 8. Now remember the rules of fractions. If the common denominator, if you get the common denominator, you're going to add or subtract the tops and keep that denominator. So 9 minus 6 is 3. 3 plus 8 is 11. And then just ask yourself, hey, self, can I reduce that fraction? We can only reduce a fraction if there is a common factor we can divide out of top and bottom. If we can't, that's done. You're good. Okay. So C, please proceed in the same way. So A and C are similar types of problems. Okay. Now let's talk about B and D, because those are multiplication of fractions. Now I'm going to let you do B on your own, but I'm going to give you a little hint. When you do B, think about that as negative 1 times 14 over 1 times 3 over 6. And we could even put that negative 1 over 1 as you go ahead and multiply that. You can just multiply tops with tops and bottoms with bottoms and then reduce. But if you see like 14 and 6 are both divisible by 2, you can reduce it first and then multiply the remaining tops and bottoms. That's okay too. Okay. But I want to do D with you now so that we can just talk about those things. Now you can just multiply and get 14x over 250. That's an option. Okay. But if you notice, both 2 and 10 are divisible by 2. So you can do that as well. No matter how you slice it, you're going to have to take out a factor of 2 to get it into reduced form. And so we get 7x over 125. And I always look one more time. Hey, is there something I forgot? Is there something I missed? Is there something I can still reduce? I cannot. Okay, so your job is to finish number 3. Do we have any questions about 1, 2, or 3? Anybody have any questions about those 3? Okay, let's talk about 4. It's just substitution again. We do have some fractions involved. There's some things I want to remind you. In part A, when we do substitute that in, again, I like to do the same thing. Where the x is sitting, I always put that little open parenthesis. But remember, anything to the 0 power is equal to 1. So be careful, because that is just going to be 6 times 1, or 6. B, I'm going to start it for you, but please finish it. When you do that substitution, make sure you surround that -2 by parentheses, because you have to take that -2 to the 4th power and then multiply by -3. So that's how you would follow order of operations there. So please continue that process for me for B. Let's talk about C. Now, C is an interesting one because of the way that the parenthesis surrounds that negative. So in C here, let me show you where you should put that little parenthesis. See, technically, my -1/3 is in there next to the negative symbol. So it's kind of a weird one, because we have to take the opposite of x before we cube it. It's all about order of operations. What touches your x first? So the opposite of -1/3 is +1/3. So that's 12 times +1/3 cubed. Now, to cube a fraction, let me remind you, to cube a fraction, just cube the top and cube the bottom. 1 times 1 times 1, 1 cubed is 1. 3 times 3 times 3 is 27. Now, you can just multiply tops and bottom, 12 over 27, and then reduce. That's okay. You can do that. You can divide top and bottom by 3 here, or you can divide top and bottom by 3 there. Doesn't matter. They'll both get you the same place. Your final answer would be 4 over 9. So please finish up number 4. Now, number 5, they just want us to follow the rules of exponents. So let's just talk about them. We'll do some of them together, and some of them you're responsible for finishing up on your own. Remember, for A, I'm going to start it, but you finish it. That's just 7x times 7x. So you're squaring all the pieces inside. B is really great because anything to the 0 power, and since this whole thing is to the 0 power, it's always equal to 1, so you don't have to think quite as much about that. C, make sure you square that second piece before you multiply by 5y to the 5th. You have to follow order of operations. Same thing for D. But what I want to do is I want to focus on E and F together, and then it'll be your responsibility to finish the other ones. Let's talk about E and F. Think about order of operations. Exponents come first. We got to do that exponent. When we do the exponent for the first one here, that is 2 to the 4th. I'm going to write it as 2 to the 4th. Well, no, I can do it, I guess. 2 to the 4th. 2, 4, 8, 16. That's 16. And that's y to the 4th. And then 4 squared is 16. And then that's y squared. Okay. We're going to multiply the top stuffs together. We're going to multiply the bottom stuff together. 16 squared, or 16 times 16, is 256. And then if the bases are alike and you're multiplying, we're going to add the exponents. The y to the 4th and the y to the 2nd are in the same location, so we're multiplying them. So we add those exponents. That's why it's becoming y to the 6th. You can't do anything else. You do want your final answer to contain positive exponents if possible, and so that's a good place to stop. Now, I want to talk about F because F has some funky problems with it. Negative exponents' jobs are to flip whatever it's touching. So our first fraction, both of them have negative exponents. So let's do the job of that negative exponent. Let's flip what it's touching. So the a to the negative 2 that's in the bottom becomes an a to the 2 on the top. The b to the negative 2 that's in the top becomes a b to the second in the bottom. Then our second fraction, we're going to square the fraction. And we square a fraction by multiplying or squaring the top and squaring the bottom. So it's b squared over a squared. Now you'll notice we have an a squared divided by an a squared, which is 1. We have a b squared divided by a b squared, which is 1. So it cancels out perfectly. The answer is 1. So please finish up number 5. Do we have any questions about number 5? Okay. 6 is a similar idea, but we do have some expressions that we need to fix. Hopefully, from what we've done in 5, that's going to help you. See how it says write everything with positive exponents. Please make sure that you're flipping anything that you have to. So for part A, I'm going to start it for you. The only thing that has a negative exponent is the y to the 6th. So it is the only thing that drops down to the bottom before you simplify. So keep going. That's not done yet. Okay. Let's talk about B. Both the negative 3, or both quantities have a negative exponent. So this is 1 over z plus 4 to the 3rd, and 1 over z plus 4 to the 9th. And then to write it as a positive exponent, the rule is if you're multiplying, add the exponents. Same level you're multiplying. So the 1's multiply, and the z plus 4's multiply by actually adding those exponents together. Now, C is a funky one, so I really want to do C and D with you. Let's talk about C for just a minute. If there is a possibility to simplify a fraction before you do anything to the outer part of it, let's deal with the inside of that fraction, and then we'll deal with that negative 5 that's on the outside. The only thing I notice that's wrong with the inside of my fraction is that has a negative exponent. The job of a negative exponent is to denote division, so we're going to have to scooch that to its right location, and so we get y to the 9 over 2x cubed. Okay. But our outside has a negative. To divide by a fraction is the same as multiplying by its reciprocal. That's why that negative that's on the outside is going to flip the fraction again. So let's flip the fraction. So that would put the 2x cubed on the top, the y to the 9th on the bottom, and now my power is a positive 5 because I've used the negative to flip it. Okay. Now I have to take everything to the 5th power. The rules of exponents say if you have a power on the inside and a power on the outside, multiply them. Okay. So 2 to the 5th is 32. So a numerical expression, just do what you do to the number. 2 to the 5th, 2 times 2 times 2 times 2 times 2, 32. Okay. X to the 3rd to the 5th, think about it. That's x to the 3rd times 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 x to the 3rd. You have 15 x's because you're going to multiply those. And then the 9, same thing. We're going to have 45 9s, or 45 y's, I'm sorry. Okay. So that's that one. And let's do D together. Same thing, because we've got some exponents there that are negative. I don't like that. I want to show you how to fix it. So the a to the 5th goes down in the bottom, becomes a positive exponent. The b to the 5th goes in the top. I guess we don't need parentheses really now that we've done that. I'll make it look a little nicer. And then this would be b to the 6th and a to the 6th. If they're on the same level and the bases are alike, you add the exponents. If they're on different levels, you subtract the exponents. The b's are on the same level, let's add those exponents. The a's are on the same level, let's add those exponents. That's it. Can't do really anything else. We have positive exponents as our final answer, so we're done. So really the only one you have to finish up in problem number 6 is part A. Do we have any questions about that one? Okay, let's move on to 7. Sorry, let's look at this one. Hopefully you know that the square root of 81 is 9, but let me show you a trick if you forget that. The opposite of a square root is a square. So if you rewrite 81 as 9 squared, then that's another way for it to pop that the answer is 9. Same thing we can do for b. Both 125 and 8 are perfect cubes, so cube root undoes that very nicely. This is the same as 5 cubed over 8, which is 2 cubed. So the 5 and the 2 are what remains, because the cubed root of 5 cubed is 5. The cubed root of 2 cubed is 2. So that is the answer, 5 over 2. Okay, so those are nice. But that leads us now to problem number 8. The rule you want to remember is the following. If you have a, you can go back or forth. For problem 7, we're going from this direction kind of in a way. The numerator is your power. The denominator is our index. So I'm going to use that to help me. And actually in part number 8, we're probably going to go this direction. So you can go back and forth between those two notations. Okay. But I'll show you mixture ways. You decide how you want to do it. Okay. So I'm going to do A and B, and then I want you to do C and D, okay? Let's talk about A and B. A. Here's my trick. 27, do you see this denominator here is a 3? 27 is 3 cubed. These match. That's what we're looking for, because that's really a cube root of a cube thing. If the bases are upstairs, if we have a power to a power, the rule is if we have a power to a power, we actually multiply those. And to multiply a 3 by a negative 2/3, the 3's cancel. And so we're just left with that, because the 3's are going to cancel, which is great, okay? Now, earlier we talked about the fact we don't want negative exponents. The job of a negative exponent is to flip whatever it's touching. So let's flip that. Now what is 3 squared? 9. So now it's just 1/9. So you can rewrite it, or you can figure out what the cube is right off the bat. And that's probably the easiest way to do one like A. You could do C almost identically the same way, okay? Except for C, you're looking for what's the square root of 25. Okay, now let's do B, and that will set you up for what you have to do for D. Let's do B together. Okay. Now, a negative exponent, we can deal with 2 different ways. We can deal with it later, hold on to it and deal with it later. But if it's touching a fraction, I just flip the darn thing, and then I don't have to deal with it anymore. So let's flip it. That's 16 over 81 to the 3/4. Okay. The negative exponent's job is to flip whatever it's touching. We flipped whatever it's touching, so now the negative is gone. Okay. Now, we have a 4th denominator there. So let's think about the numbers 16 and 81. 16 is 2 to the 4th. 2 times 2 times 2 times 2. 81 is 3 to the 4th. So what's great is we can just now multiply those in, and the 4's are going to cancel, because the 4th power and the 4th fraction denominator cancels out. And so we get, this is just 2 to the 3rd over 3 to the 3rd, which we know how to do. 2 to the 3rd is 8. 3 to the 3rd is 27. Always think in your head, can I reduce that down further? I cannot. That's done. Okay. So now your job by the end of class is to finish whatever we have it for 1 through 8, and you're going to turn this in each day with just the pieces that you get done. So problems 1 through 8. Remember, grades pretty much are done. What you see in progress book, unless you tell me otherwise, is your grade. 6A, 6B, the December Achieve, and the stuff we're doing this week is all on the new 9 weeks. And those are the only thing that you can still turn in late. I'm okay with you turning them in late because that's going on next 9 weeks. But for the remainder of class, finish 1 through 8. Tomorrow we're going to do 9 through 12, then we'll do 13 through 17, and then we'll do 18 through 20. Each day we're going to kind of do parts of this to remind us of all our algebra facts, okay? So there you go. Do your thing. There we go.